Good morning, everybody. Thank you for taking the time out of your day, especially on a Friday before a holiday, to join us for this presentation. We're going to cover what you need to know about CO2 cleaning. The purpose of this webinar is to talk about CO2 cleaning, what it is, and how it can be effectively deployed as a tool to care for your PPE. At Gear Wash, CO2 cleaning is one of many options we offer. It's important to point out I am not a CO2 expert. In fact, I'm far from it. My goal with this webinar is to level set expectation with capabilities for what CO2 cleaning methods for PPE can provide. Now, I know there may be a few times where you might come away with the feeling that I'm picking on CO2. I assure you, I'm not. All I'm attempting to do is level set expectation versus incomplete information that's currently in the field. My name is Brian Marenko. I've been working in the fire industry for 29 years with a focus on all things cleaning and care. I spent much of that time in the field helping and teaching end users how to implement NFPA 1851 programs, be it in-house, with an ISP, or a hybrid of both. CO2 cleaning, while a new offering from Gear Wash, has been around for a while. It's been mostly used to clean delicate surfaces in aerospace, automotive, electronics, medical, and other industries. CO2 cleaning is another tool in the cleaning and care toolbox. CO2 cleans using liquid carbon dioxide instead of water. It naturally sticks to contaminants found on turnout gear and can provide a deeper level of cleaning. Popular belief is CO2 removes 100% of everything. This simply is not true. We'll talk more about this in the next couple of slides. CO2 cleaning is a closed loop system, no water used, therefore there's less waste. Wash programs are designed specifically for PPE materials. Let's review some of the claims in the fire industry for CO2. Contaminant removal. The claim is up to 100% removal rate. The reality, 100% applies to contaminants it was tested to remove. Fun fact for you. Regular washing using washer extractors have also been test proven to remove up to 100% of some contaminants as well. Again, just keeping this in perspective. To pass current NFPA 1851 cleaning validation requirements, an organization or an ISP must demonstrate a 50% on average contaminant removal rate. To put this into perspective, if you were to have six contaminants to remove, you remove 100% of the first three and none of the remaining three, you would pass with a 50% average removal rate. Your cleaning process would be 1851 verified to meet current edition requirements. Here's an example of NFPA 1851 cleaning validation process mandated for ISPs. Remember, organizations are not required to do this, only if they elect to. An ISP receives a scaled down set of gear with mesh pockets sewn on in various locations. Take a look at the white paper on the desk in the photograph. It'll give you a better idea of where those mesh pockets are. Next, what happens, there's test swatches that are placed inside the mesh pockets. They're inoculated with contaminants noted on the next slide I'm going to cover and placed inside each pocket. Documented cleaning process, as noted in the ISP's organization's quality manual, is audited by either Intertech or Underwriters Laboratories. They do this in person or virtually, and they watch it from start to finish. It's a very long day for everybody involved. From that point, the gear is dried, swatches are removed, placed in Petri dishes, and overnighted to the lab so results are generated. Here's a list of contaminants required by NFPA 1851. Now, I can tell you I can't pronounce half of these contaminants on the screen, but I think you'll agree this certainly doesn't cover all the contaminants that could be on turnout gear at any given time. Likely there's thousands more that remain on turnout gear that have had no testing and quite frankly, no one knows to what extent anything can be removed. Remember, on the previous slide, I talked about an on average removal rate of 50%. These are requirements set forth by NFPA 1851 for both groupings. So each group, you have to demonstrate a 50% removal rate. CO2 alone does very well with semi-volatile organic compounds, but it doesn't do as well with heavy metals by comparison. Usually to pass heavy metal removal requirements, some form of pretreatment, maybe even using a regular washer extractor, is used prior to the CO2 process in order to pass the 50% on average removal rate set forth by NFPA 1851. That's right. A regular washing machine can sometimes be used before the CO2 process to help pass heavy metals. At the end of the day, you can always ask your third-party cleaning care provider to view their wash process so you can see for yourself exactly how the results are achieved. Another claim, electrical vehicle fires. The claim is CO2 removes all EV contaminants. The reality, industry doesn't know at this point in time all the contaminants in an EV fire. More work needs to be done and is underway to better understand what's not only in EV fires, but components, products of combustion from interior of the vehicle. Ideally, you would like to test for known contaminants post-exposure and post-cleaning in order to learn if they were adequately removed. Currently, very few agencies have this ability today to do this level of testing in-house. Another claim, dry gear. Wet gear can be washed in CO2. The reality, CO2 does not handle wet gear well. Reduced cleaning efficiency, along with gear coming out of the CO2 machine that still will remain wet. If you use water to put out a fire or follow NFPA 1851 recommended preliminary exposure reduction recommendations, like in the photo shown, you are likely to have gear that is too wet to be placed in a CO2 machine. So what do? Do you dry dirty gear? I mean, think about it. How do you dry dirty gear in a building? Very likely to have contaminants blow throughout the building. So very tough to do that safely. And as we all think about, it's probably not a good idea. Or do you place gear, the wet gear, in a washer extractor to first wash it, remove it, dry it, and then place it in a CO2 machine? That scenario is more than likely what happens. Conventional washing. The claim is washer extractors are obsolete and should no longer be used to clean PPE. The reality, it's not true. Washer extractors still have a place cleaning PPE. Gear contaminated with construction debris, for example, drywall, insulation materials, will need to undergo cleaning to remove the surface contaminants before CO2 cleaning can occur. Just like CO2, washer extractors are a tool that can be used to wash gear. I personally toured some CO2 facilities and have seen regular washer extractors on site near CO2 machines. Why is that if they're no longer needed? Disassembly of gear. The claim is entire garments can be washed without removing the inner liner. The reality, not if you want to be compliant with NFPA 1851. Section 7.3.11.2 requires separable liners and shells to be cleaned with like components. Look, even a future edition of 1851 permits gear to remain assembled for CO2, you will still need to remove the inner liner from the outer shell to perform advanced inspections and or when you need to do repairs. The only example where saving time is saved or gained is when gear is either in like new condition or brand new condition with no wear and is not due for its annual advanced inspection. It would be the exception rather than the rule. You benefit from not having to remove the inner liner. CO2 has a place in the cleaning and care toolbox. Like many things cleaning and care, it's not what you use, it's how you use it. CO2 is sustainable. It's good for all brands of PPE. It can be used as another method to restore your gear to a battle-ready status. CO2 is great at removing semi-volatile organic compounds, fuels, tar, petroleum byproducts, and paint. It's also more efficient than conventional ways to remove the same contaminants. CO2 is a viable tool. Gear Wash is able to provide organizations who desire CO2 cleaning. Again, my goal with this webinar was to level set expectation with capabilities for what CO2 cleaning methods for PPE can provide. It is our hope you come away from this webinar with a much better understanding of how CO2 is deployed, along with still relevant washer extractor cleanings. Thank you for your time. Hope you have a great weekend. I'd like to open it up for any questions.
Ryan, we have one question. They're asking, can the gear be damp to use the CO2 cleaning, or does it have to be completely dry?
It can be damp. It just cannot be wet, like saturated with water. Damp will work. It's just if it's dripping with water, that's going to be an issue. And the issue would be that the gear would need to become dry in order to put it in there. So likely it would then be placed in a regular washer extractor, washed, completely dried, and then put in the CO2 machine for the CO2 application.
Okay, we have a couple other ones coming in. What are the cleaning times for CO2 cleaning?
They're similar to regular washing machine. You're probably looking at about 45 minutes to an hour from start to finish.
Another one is, what effect has CO2 cleaning on a mask, for example, as it can't go through the material compared to textiles? How is it a benefit?
With a SCBA mask, to be clear?
It just says mask. Oh, yes, SCBA.
Okay. Yeah, when we get into air packs and masks and the like, we reach out to those manufacturers for guidance. There have been occasions where we've received approval to place it in the CO2 machine. It does a fine job for where we can.
Okay, we have another one. Will PER cleaning products not completely rinsed out affect the process?
I think I need more clarification. So you're saying immediately after PER to place the gear in the CO2 machine? Is that the question?
Like he said, like Dawn or dish soaps.
Okay. Likely that gear will need to be pre-treated first, washed in a regular washer extractor. Reason being, that gear is likely too wet to be placed in the CO2 machine at that point, and would need to undergo regular cleaning to get it to a point in place where it could be placed in. If you were to place it in wet with detergent on it, what would happen is the gear would not come out as clean as you would expect it to, and would also come out with residual dampness water, if you will, as a byproduct of being wet when it was introduced to the machine.
We have another one. What should be some standard exposures or scenarios that should prompt us to use CO2 cleaning, in your opinion?
It's widely used. There are departments that would like to use CO2 for all their annual cleanings, for every cleaning done, performed, and that's certainly the department's prerogative to do that. For us, we have found it to be beneficial with certain types of contaminants, like fuel. For instance, current practice with contaminated equipment with fuel would be to take the set of gear, soak it in a tank with various cleaning agents, wait a little while, take it out, We would then scrub it, and if that wasn't adequate, we would return it to the soak tank. And at the end of the day, there's a level of hope that traditionally what we're doing is going to work. One of the advantages of CO2 is we know the outcome. It goes into the vessel, it comes out without the fuel on it. There's no waiting, there's no soaking, there's no hoping. So that there is an efficiency and time savings, and also in cleaning and being able to have a desired result, after the first time. That said, if you have other contaminants that are on turnout gear that you're not having a high success in removing, and if you're faced with either discarding, retiring that set of gear, it may be worth the investment to try CO2 cleaning, because at that point, what do you have to lose? It's either going to become clean or it's going to end up being removed from service and disposed of. So across the board, many different applications. We use it very differently, and in all occasions, it's at our customer's direction. It just depends on where you want to go with it.
Okay. Another one, some ISPs are claiming CO2 cleaning removes lithium smoke. What is your comment on these claims?
You need to take a look at the test results. It's one thing to make a claim. It's another thing to validate the claim. I don't have enough information to say either it does or it doesn't. If I'm asked, that's the road we go. We're happy to continue to test this technology against the different contaminants, but at the same time, we don't quite know for sure what the contaminants are in that smoke. So it's really casting a broad stone, so to speak. But at the end of the day, we have to test. We have to know what we're testing for, and then we have to know if we're able to remove it.
Okay, our next one says, since you covered what CO2 excels at, what are things that it struggles with?
It struggles with, and I guess the best way I could phrase this would be construction debris. So think of drywall, think of building insulation, you pull ceiling, any kind of matter that or debris that gets on the turnout gear needs to be pre-treated, washed ahead of time of doing CO2. I mean, what happens if you place that in the CO2 vessel without doing that? It's very difficult to have those things removed, and it also has an effect on the drains, on the filters within the CO2. Makes it very difficult. You save yourself a whole lot of time by doing that laundering up front before you put it in the CO2 machine. So really, that's the drawback. When you've got those type of construction materials on your gear, putting it straight in the CO2 machine will not give you the desired result that you are hoping for and expecting. Other things need to occur before that result happens.
Great. Does CO2 cleaning replace regular cleaning?
It can if you want it to be. I mean, there's room for both. There are some things regular water washing does better than CO2, and there's things that CO2 does better than regular water washing. And then there's a hybrid of both. There isn't anything wrong as a department if you want to do all of your cleanings with CO2. You can certainly do that. It doesn't void NFPA 1851. But at the same time, if you continue with regular washing, that's fine too. We're all held to the same metric in terms of cleaning validation, and we're tested once every 18 months for those abilities. So as long as you're meeting the metric within 1851, either way of cleaning is a way to go. Really up to the department.
Okay, our last one right now says using CO2 cleaning to remove contaminants. How are the removed contaminants collected and disposed of?
They're collected in a filter, and then that filter is then taken to a third party. A third party comes, takes it away, and it's disposed of according to local, state, and federal guidelines. Um, Not too much fancier than that. It's a filter replacement that occurs.
Okay, we just got another one coming in. Will 1851 standards or 50 standards include CO2 cleaning?
There will be provisions in the upcoming edition. Really, it's not just for CO2 cleaning. It's allowing various types of cleanings, so it's not as restrictive. I mean, there's going to be a new level of cleaning, probably a couple years down the road that none of us even know of right now. And what 1850 is attempting to do is to make it a very broad regulation as to what type of equipment that you can use, and not be exclusive of other upcoming technologies. That said, there's also going to be extra cleaning validation requirements as an option that a third party could look into doing to prove out that they're able to remove certain types of contaminants. But at the current time, the 1850 standard is still under revision. Things could change, but for the most part, that's where things seem to be headed.
Okay, we have one more. Do you believe scrubbing is part of the advanced cleaning or specialized cleaning process? And should the customer be told that their gear is being scrubbed?
Yeah, scrubbing crosses over into the specialized cleaning. By definition, you've got three levels. You've got the preliminary exposure reduction, which is a gross decon, as you saw in the photograph on one of the previous slides. The second level of cleaning is advanced cleaning, and by definition, it's mechanical action, washing machine, if you will. And then the third level is specialized cleaning. This is when you get into contamination, like tar, motor oil, things that just a preliminary exposure reduction and a regular advanced cleaning just do not seem to handle. So to utilize a scrub brush definitely lends itself more toward a specialized cleaning, although it's not restricted from advanced cleaning at this point, so one could do it if they wanted to. But the intent of advanced cleaning is using a washing machine. And yes, if scrubbing is occurring, I always believe an ISP should be transparent with their customer fire department on processes that they're utilizing. That's we have an open door policy. We allow customers to come in, walk through our facility, and view what we're doing. And absolutely, I think those things should be disclosed to the customer so they know level of service that they're receiving.
All right, last one for now. Are ISPs required to be UL certified to utilize the CO2 cleaning process?
ISPs are required to be third-party verified. So UL is one provider of it. Intertech is another provider. It's at the ISP's option as to which agency they want to use. If an ISP has a CO2 machine, then and that's part of their process for their cleaning validation, then yes, that would be validated through the third-party cleaning validation process. However, if they do not have a washing machine, or I'm sorry, a CO2 machine, their process is validated against the equipment that they have. I hope that answers the question. If not, please feel free to ask additional.
They said yes, it did.
Okay.
Okay, we'll give it a few more seconds to see if there's any more questions coming through, but that's all I'm seeing right now.
Okay.
All right, I'm not seeing anything, so I think we are good to wrap up.
All right, 4 minutes back for your weekend. Hope everyone has a great weekend. Stay safe. We'll talk to you soon. Thank you.